Okay, let's review reactivity. I thought you could probably see the screen better like this, so that's why it's dark. I labeled all of the valence electrons on here already, like you've been doing in your brain up, because valence electrons determine reactivity. If we know the valence electrons, we know how reactive it is. We just have to memorize a few things. So let's start with group 18. Remember, I say to give group 18 a crown because they have all 8 valence electrons. So they are stable. I think of them like royalty. Stable means they're non-reactive, so they're not gonna mess with anyone else. They're good all on their own. So you know, like royal people, they don't need anyone else. They're good all on their own. They're also called the noble gases. So every element in this group is a gas and it's non-reactive. Another word for non-reactive is stable. In group 17, they get a fire flame because they are very reactive. They want to be stable. Being stable is like goals. That's what everyone wants to be. They want to be stable. If they can get one more valence electron, they are stable. So they're going crazy. So I'm just going to put a little reminder. I'm going to put VR. They're very reactive. And then this group is stable. And then if we go to group 1, they also get a fire flame because they are very reactive. If they can give that one valence electron away, then they get to be stable, which is goals. So group 1 and group 17 are very reactive. They want to get rid of one valence electron or get one more valence electron so that they get to be stable. The other groups, group 2, 3, 4, 5, 6, these ones are all reactive. They react. They definitely still react. They're just not very reactive. They have a lot more work to do in order to become stable. Think about it. If they're in group 14, they have 4 valence electrons. They have to get 1, 2, 3, 4 more to be stable. So they have a lot more work to do. That's why they're just reactive. Very reactive, stable, very reactive. What's kind of cool, another important thing to remember, is that every element in the same group reacts similarly. Every element in group 17 has 7 valence electrons and is very reactive. Let's look at reactivity in a Bohr model. Some of your questions today will have Bohr models, and can we determine the reactivity from a Bohr model? Yeah, we have a lot of information in Bohr models. Bohr models give us tons of information. So remember, valence electrons determines reactivity. Valence electrons are the electrons on the outermost energy level. So let's count. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 valence electrons. Okay, if there's 8 valence electrons, what group is it in? Think about what we just labeled. It's in group 18. What did we say about group 18? They get a crown because they are stable. So this element is non-reactive. It's good all on its own. It is not going to react, it's stable. Let's look at this element. What if a question asks us which element is more reactive? Well, we'd need to count the valence electrons for this element. So 1, 2, 3, 4, 5, 6, 7. There are 7 valence electrons. So what group is it in? It's in group 17. So if it's in group 17, it has 7 valence electrons. It is very reactive. So this element is very reactive. This element is stable. So which element is more reactive? This one. I knew that just by counting the valence electrons. They could give you 20 Bohr models. You can count the valence electrons and you can decide what element is the least reactive, what element is the most reactive. Remember, valence electrons determine reactivity.